This is video 5.5.1. We're going to talk about solving trigonometric equations in this section, and in today's we're just going to look at some basics and understanding how to find all solutions. So I have my unit circle handy because we're going to be looking for angle measures that have certain trig functions. So since my unit circle has them all worked out for me, I'm going to use that to my benefit. So let's take a look at this first example here. Remember to be taking notes and to bring your questions into class when this assignment is due so that we can go over it and get you help on your assignment. So let's take a look. The first example. One of the reasons why this is just a basic trig function is all you have to do here is get your sine x alone. The only function you have here is sine of x. You don't have any cosines, tangents, nothing squared. So we're simply going to isolate sine of x, and I'm going to do some simple steps to do that. I'm going to start by subtracting 5 sine of x from both sides. Part of my writing here, let's see. Subtract 5 sine of x from both sides. Looks like we'll have negative 2 sine of x minus 2 equals negative 3. And we're going to add 2. We're simply isolating the sine of x. Negative 2 sine of x equals negative 1. And my final step, of course, is divide by negative 2. And I get sine of x alone equals positive 1/2. So we've gotten the sine of x alone, just like it was a y or an a or a b. But now we're looking for all x values that have a sine of 1/2. So now this is where my unit circle comes in. I can plug this into my calculator, but remember your calculator only gives you one answer. We actually want to find all solutions. The instructions didn't say that, but if it doesn't say that, we definitely want to give as many solutions as we can. And here's how you do that. So we look on our unit circle, we find where sine is 1/2. It looks like we have sine equal to 1/2 right here. We also have sine equal to 1/2 over here, because sine is positive in the first two quadrants, and those two have the same y value. But keep in mind, there are an infinite number of angles where sine is 1/2. Because I could go to pi over 6 and then go an additional circle. This angle that starts at 0, goes to pi over 6, and goes one more full circle will have the same sine as pi over 6. So the way we describe that is we say, okay, the possible values for x are pi over 6 plus any full circles, and a full circle in radians is 2 pi. But we could go one full circle, we could go two full circles, we could go backwards a circle, and we would still land on pi over 6, and we therefore still have the same sign. So the way we describe that is we say 2 pi n. And in addition to this, we're going to say for any integer n. That tells everyone that we can add 20 n's. We could put 20 in for n, we could put negative 10 in for n, and that's simply the number of full circles we go for any integer n. Now that's not the only one. Remember 5 pi over 6 was the other angle. But once again, I could go straight to 5 pi over 6. Or I could go to 5 pi over 6, then go one more full circle. That's still going to have the same sine value. It's still going to be 1/2. So we describe that one as 5 pi over 6 plus 2 pi n again. Because I could go any full circle past 5 pi over 6, or I could go to 5 pi over 6 and go backwards 2 circles, and I would still have a sine of 1/2. So my solution set is these two equations, these two expressions that describe the possible values of n. And this is, of course, for any integer n for both these two. So that's how we describe solutions. That's pretty interesting because what we're trying to do is think back to our Ferris wheel problems or temperature. Remember when you did your projects and you were looking at temperature and you were trying to describe that the temperature in March is going to be very comparable to the temperature in October because of the fact of this cyclical pattern. But every October in the future will have the similar temperature. And that's the same idea here. We're trying to describe every situation where we'll have the same sign. That's the first example. We're going to look at one more with tangent that throws us for a smaller loop here. So let's see here. Now we have tangent of 4x equals 1. Good news is the tangent is already alone, but we have that 4x on the inside. So our first step here is going to be the same. We're still going to we're still going to take a look at our unit circle and find out where is tangent 1. Tangent of what angle is 1? Okay, tangent is slope, and I see the tangent is 1 here at 45 degrees, or pi over 4. Once again, I can go full circles from pi over 4, but tangent is unique because you can in fact not just go a full circle, but from pi over 4, I could just go half a circle, and I have the same exact tangent. If I divide these two numbers and find the slope, I will also get 1. So tangent has solutions for this particular case. It's every pi over 4 plus half a circle. So just pi times n. Okay, so once again, we're looking at trying to describe all possible values where tangent is 1. Okay, we didn't want to just know where tangent was 1. We wanted to know what x's make this equation true. So we're asked a different question than what we've already answered. We're asked what x could I plug in right there and get a tangent of 1. Okay, so we're looking for when will I get this answer if I'm plugging in 4x. Okay, I want 4x, this quantity here, I want this 4x over here to equal, this, and I want to figure out when that will happen. Okay, so I'm solving for x once again, and I'm looking for when that's going to happen. So I'm going to divide both sides by 4. Everything divided by 4. Let's see what I get. So I get x equal to pi over 16 plus pi over 4 times n. These are the possible values where I will get an angle, an x value, that when I plug it in, I will get a tangent of 1 back up in this equation. Okay, here's why this works. If you're not totally convinced, let's take a look at some examples. So let's say I want to know when is 4x equal to pi over 4, because I know that if 4x is pi over 4, I'm going to get a tangent of 1. So I'm going to divide both sides by 4, and I'm going to get x equals pi over 16. There's one solution. Okay, but now I got to do it again. Now I got to say, okay, well, when will 4x give me 5 pi over 4? Because that's another potential answer. Well, I divide both sides by 4. See a common thing here? It looks like I'm dividing by 4 again. 5 pi over 16. I check my answers because I don't want to go too far. I see pi over 16 and 5 pi over 16. And I check, okay, have I gone past my range of 0 to 2 pi? Looks like I haven't. Pi over 16 and 5 pi over 16 are both well within that range. So I'm going to keep going. Now I'm going to say, okay, when is 4x equal to, well, let's see, I'm going to add a full circle on. So I'm going to see, okay, pi over 4. So off to the side, I'm going to add on full 2 pi. Because if I go full circle, it'll still have a tangent of 2. Well, that's just 8 over 4. So 9 pi over 4. So I'm going to solve this equation. When is this? 9 pi over 4. Once again, I'm going to divide by 4. And I get x equals 9 pi over 16. Another solution, once again, that is within my range. Okay, so let's see. I have every single time simply divided by 4. That is why solving this equation is going to help you kind of allow you to quickly manipulate and plug in things. We have found 3 solutions. Okay, one of your checkpoint exercises is to try and find the other solutions. We're not done. We have to keep going. We have to keep going until we get answers that are bigger than 2 pi. That is my goal. The goal with this question was to find all solutions between 0 and 2 pi. We've found 3 of them. There are many more. So keep going and finding all the solutions where we get an answer of tangent of 4x will equal 1. I will check your answers on that tomorrow. There are 2 more questions that I'd like you to answer. And they are questions, checkpoints 1 and 2, as you see here. So solve these 2 checkpoints, give them a shot, see if you can get them started. We'll talk more about how to find all of the solutions in class when we go over these checkpoints. But these 2 questions are due with your notes on Wednesday.